what did we find? Well, we were able to find the critical point. Now we found the critical point. We found g prime of x to be 4e4x minus 6e6x. We also found g prime prime of x to be 16e4x minus 36e6x. And then the critical point that we found it was ln of 2/3 to the power half, comma 4/27. What else? We say the function g is increasing on negative infinity up to ln 2/3 power half. And g is decreasing on ln 2/3 power half, comma positive infinity. Okay. Then what else? We also said this is relative maximum. We now want to check where it's concave up and concave down. So we equate the second derivative to 0. We solve g prime prime of x is equal to 0, which is solving 16e4x minus 36e6x is equal to 0. So we take the other side. So we remain with negative 36e6x is equal to 16 minus e4x. Again, we divide by e4x and negative 36. We also divide by negative 36 and the e4x. So that this negative 36 can cancel and the e4x can cancel this side. Then they remain. Here we have e6x over e4x is equal to negative cancels. So you get 16/36. We can use 4. 4 can go into 16 4 times. 4 into 36 9 times. And then this gives us, because of the same base EE, we subtract the powers. So we have 6x minus 4x, giving us 2x, which is equal to 4/9. When we apply in, So when we apply in, we'll have 2x coming down, and then we'll get ln 4/9. Divide by 2. Divide by 2 here. This will give us x is equal to 1/2 ln 4/9, which is x is equal to ln 4/9 to the power half. Now power half is like the square root. So this is telling us that x is equal to ln, the square root of 4 is 2, the square root of 9 is 3. So this is our x.
So,
Hello.
so is that value of x the inflection point?
The value of x that we got as an inflection point was, we haven't determined the inflection point, yeah. Let's say now I want to determine the inflection point. So what do? We have found this value of x now. We want to test concavity here. Is it concave down? Is it concave up? At which interval is that the case? So we pick the value, mean 2/3. Of course, this is a negative number, but it's a very small negative number. So I know if I'm looking for a number bigger than it, I can pick 1. A number less than it, I can pick 0. So get G prime prime to test. So we substitute 0. So G prime prime of 0. G prime prime is here. So when I put 0, I will get 16. E 4 times 0, we get 0. Minus 36. E 6 times 0, we get 0. So we have 16. Remember, E power 0 is 1. So we have 16 minus 36, which is equal to minus 20. Hello?
Isn't 0 greater than ln 2/3?
Hey. You are right. It's a negative value. Yeah. Let's pick it on the right. Then on the left, we'll pick -1. Yeah. Because it's 0 point something. So the 0 one, which you have used, it just gave us negative, so we put negative here. So this one has given us -20, so we put a negative there. Then we pick 1, -1. The numberless, that would be 16 E minus 4 minus 36 E minus 6, which becomes 16 over E4 minus 36 over E6. So the bigger the denominator, the smaller the quantity. So this is positive in nature. So where it is positive, it's concave up. So we're saying G is concave up on negative infinity up to ln 2/3. And concave down on ln 2/3 up to positive infinity. What does this mean? It means that the point of inflection is the point ln 2/3, comma. We now go and look for the x value corresponding to this by taking ln 2/3 in the original function. So we're now looking for G of ln 2/3. That is E4 by ln 2/3 minus E6 by ln 2/3. Which is what? Which is E ln 2/3 power 4 minus E ln 2/3 power 6. So E ln goes, so we remain with 2 over 3 power 4 minus 2 over 3 power 6. Let's say power 6. Yeah, power 6. And what number is this? This is 2 power 4 is, or I can use some other ways. I'll factor out 2 over 3 power 4 because it's common. Then we'll remain with 1 minus 2 over 3 power 2. Yeah. And then 2 over 2, 4 now, that is 16. Over 3, 4, that is 81. Multiplied by 9 minus 4, that's 5 over 9. So that's the structure. So this number here, we bring it here 16 times, then find the active value. I'm interested. 16 times 5, that is 80 over 81 times 9, 37.9. So this is the point of inflection. Where concavity changes, then it's the point of inflection.
So can we also pick the point of inflection from at a point where the second derivative is equals to 0?
Yeah, that's what we have done here. Where we get the second derivative to 0 for us to get that point. In fact, that's what we want. That's why we had to get it to 0. Okay. So now we can sketch
Then,
the
sir,
function.
if the points, the like the signs there are consistent, like if positive, positive or negative, negative, that wouldn't have been the point of inflection.
No. Because a change of action, the change of concavity is what brings about inflection point.
Okay.
If it was concave up throughout, then there's no inflection point. Okay. So now we sketch. What do we have? We have the critical point, which is a relative maximum turning point, ln 2 over 3. That's a negative number, so I'll put it here. Ln 2 over 3 to the power half, which is just the same thing as ln square root of 2 over 3. Because half is the same as square root. Okay, comma 4 over 27, comma 4 over 27. I'll put it here. 4 over 27. Yeah. Okay. Then we're saying it has a concave at ln 2 over 3. So that is somewhere here, ln 2 over 3. comma 80 over 7 to 9. That's somewhere here. 80 over 7 to 9. So somewhere here. It's concave. It has a point of inflection. So it's concave up, then concave down. Okay. Then, while we have the function we are sketching is g, does it have intercepts? Let's try and see. Can g be 0? Can g be 0? What is g? It's e4x minus e6x is equal to 0. Let's see. This is e4x is equal to e6x. Divide by e4x. Divide by e4x. So what are we getting? 1 is equal to e2x. When I apply ln, we're going to get ln 1, which is 0, is equal to 2x. So when x is 0, we have this guy is 0 when x is 0. So it means it's touching here. Okay, so the other side is not touching. So it means that this x-axis acts some kind of an asymptote kind of. So to sketch, we'll have our function. So it's coming from wherever it's coming from, acting a bit of some concavity up, and then there comes and cuts like that. Are we having? So because the bases are the same, so we subtract the powers. So this, how do we get to 2x? We are doing e6x minus 4x, giving us e6 minus 4, that's 2. That's how the sketch comes out. So on the left here, it's a bit of a bit hard to sketch, but I think I've tried. Because we want it to come like this, wherever it's coming from, like a bit of some concave, then a bit of some west, then concave. It does like that. Not that it changes per se, but just it does a bit of some resting before it picks up. Okay, so let's do, so this is 0. So let's do, somebody asked that we should do D. Is it D? D.
Yes.
Okay, so let's do D. D, we have the function f of t, but there's a variable x meaning it's f of x. X multiplied by root x squared plus 1. So first thing, we differentiate this. So differentiate this, we'll first write it as x squared plus 1 to the power half. And then use product rule. by letting u be x, and then quickly differentiate u to get 1. By letting v be x squared plus 1 to the power half, and then differentiate it, we get half x squared plus 1. Half minus 1 gives us negative half, and then x squared plus 1, we differentiate and get to x. So there I've used chain rule. So these two and these two will go. So this will give us x over, because of the negative power, I can bring it down, and because the power is half, the same as x squared plus 1. Then now we put together. So what is f prime of x? It is u prime v plus v prime u. So what is u prime? That is 1 times v, which is root x squared plus 1. And then plus v prime, that's x over root x squared plus 1 multiplied by x, so this x becomes squared. Ultimately, after we find the first derivative, we always want to equate it to 0 so that we can find the critical points. So the common denominator here becomes the root of x squared plus 1. 1 into that root, we get 1. I mean, we get the root itself. Root times the other root, only the inside remains. Plus root into itself, that is 1 times x squared. To get x squared is equal to 0. If we cross multiply, 0 times root, that becomes 0. Then we have x squared plus x squared. We get 2x squared plus 1 is equal to 0. So as you can see, this can never be 0 on the set of real numbers. So it means this function has no critical values. So we have no critical points. That are real numbers. Maybe I should mention that we have no real critical points. So if we have to use a complex, then we get x is equal to plus or minus the root of -1 over 2. And we get this to 0. We take one other side, then divide by 2. We have x squared is equal to -half. Then the square root is cancelled and we get 7. Now we know, even if we find the second derivative and test the critical points to classify them, there will be nothing like that. Okay. That won't happen because of the nature of the function. So it has become so bad that we abandon it today. It doesn't qualify to be so. Then there's one thing I didn't talk about. Did we? No, I think we didn't. First principle. So differentiation by first principle. We use first principle to differentiate. If you're given y is equal to f of x, we say dy dx, which is the same thing as f prime of x, will be given by the limit as h equals to 0 of the function f of x plus h minus the function f of x, and then divided by h. There we go. So we do an example. Question 1, we are given f of x is equal to x plus 1 over x. Before I even bring out the formula, I know in the formula there will be f of x plus h. How do you get f of x plus h? Where there is x, you put x plus h plus 1 over, where there is x, you put x plus h. Now we go to the limit. The limit as h equals to 0, f of x plus h, that is x plus h, plus 1 over x plus h, and then minus f of x is the whole x. And then I'm expanding it, so minus x, 1 over x. I mean. Everything we divide by h. It becomes the limit as h equals to 0. The common denominator, I know this is 1, that is 1. So the common denominator is going to be x multiplied by x plus h. Of course, over h here. So when we substitute when you divide 1 into x plus h, we get the whole thing. Then we multiply by x plus h up there. So we're doing x plus h multiplied by x multiplied by x plus h. So this is x multiplied by x squared plus 2xh plus h squared. So that we get x power 3 plus 2x squared h plus x h squared. Then pick that and substitute here. X3 plus 2x squared h plus xh squared. And then plus h plus x into x, h plus x will remain with x there. And then 1 into x, x plus h. We'll get x, x plus h, and then multiply by the x up there. X plus h. This will give us x power 3 plus x squared h. But there's a minus here, so I'm multiplying everything by minus. So I get to minus x3 minus x squared h. Then x into x plus, x multiplied by x plus h. We have x plus h, then multiplied by -1. So we get minus x minus h. Well, our interest is seeing this x at the end of h getting cancelled by this one. This x3 without h getting cancelled by this one. The remaining ones, we're okay with them because they have h. So they help us extract an h that will take away the h that is down to. So we have the limit as h equals to 0 of what? Of we factor out h from top there. Now we're remaining with 2x squared plus xh minus x squared minus 1, and then divided by x plus h divided by h. So this and this can cancel. Then wherever there is h now, we substitute 0. So we have 2x squared plus x times 0, that is 0, So minus x squared minus 1 over x squared. So this becomes the derivative that we get via first principle. I'll leave you with a homework to make sure that you check if you understand fully sheet 9 and sheet 10. That should be okay. Okay. So I leave with a task to make sure that the sheet 9 and the sheet 10 is well understood. I think around 20 something tomorrow, we'll have a continuation of this revision and it will intensify on Friday and more dense, of course, on Saturday. No. So let's browse through so that if you have questions on the sheets 9 and 10, please make sure that you put them up in the group, to ask them in the group, so that when we have a session, we start by answering those, like we have done today.
Sorry, sir, for taking you back.
Yeah, you're taking it back.
Yes, sir, I just wanted to find out where you have next, right? Yeah, so where you have found, where we have found, where you said there was no critical point, is it because we found the value inside the square root or what?
Is it because?
Is it because there is a negative value inside the square root or what?
No.
That negative 1/2.
No. Oh, you mean here?
Because of
because this is not a real
why we
number.
okay.
Yeah, in this course, I think we don't plot the imaginary points. That's why I've left it that there's no critical point, because we are using real values here, real critical points in this course.
Okay, sir. Thank you.
Okay. Before anyone takes me back, good night.